Hello students, welcome to my YouTube channel. Today we are going to start a new chapter called functions. Basically this is the overview of the chapter. Today we are going to cover the first two topics, that is function as a special kind of relation and function as a correspondence. Let's see this too. Function as a special kind of relation. Let A and B be two non-empty sets, then a relation F from A to B is a subset of A cross B is called a function from A to B if it satisfies these two conditions. First condition is, for each A belonging to the first set A, there exists B in the second set capital B such that this ordered pair A comma B belongs to F. And the second condition is that if this ordered pair AB belongs to F and AC belongs to F, then B equals to C. Means how to identify whether a relation is a function or not. We want to learn this. See here. Thus, a non-empty subset F of A cross B is a function from A to B if each element of A appears in some ordered pair in F, and no two ordered pairs in F have the same first element. So, we need to have each element of A to be appeared in some ordered pair, right? And no two ordered pair in F can have the same first element. Now let us understand this definition with the help of an example. See, consider two sets. Let's say this is set A, which consists of 1, 2, 3, and set B, which contains 2, 3, and 4. And say F1, F2 and F3 be three subsets of A cross B which are defined below, right? See, in the first case, F1 is a 1, 2 means 1 maps to 2, 2 maps to 3 and 3 maps to 4. Now clearly this F1 is a subset of A cross B. So is F1 a function from A to B? We want to check it. See, here the first element is what? Here the first element is 1 over here. Here first element is 2 and here first element is 3, right? So no ordered pair, sorry, yes, means every ordered pair have different first element, right? Means no two ordered pair have the same first element. So F1 is a function from A to B. Now check for F2. See, F2 consists of this ordered pair is F2. This consists of 1, 2, 1, 3, 2, 3 and 3, 4. Now see here, 1, 2 and 1, 3 means two ordered pair have the same first element, which is 1. Therefore it violates this condition, right? That no two ordered pairs in F have the same first element. So F2 violates this condition. Therefore F2 is not a function. You can see the arrow diagram of F2 as well, right? Means the image of the set A cannot have more than one image in set B, right? We can conclude this from here. Similarly, in case of this f3 is 1,3 and 2,4. See, no two ordered pair have the same first element, right? Here this ordered pair has 1 as the first element, and here this ordered pair has 2 as the first element. See the mapping diagram. But this should not be a sufficient condition. See this. See the first condition also, that each element of A appears in some ordered pair of F. This is also the condition, right? There were two conditions, first and second. Means every element of A shall map with the element of B, and no element of set A can have more than 2 images, right? So here this 3 has no image in B, therefore f3 is not a function, as 3 which belongs to the set A has no image in B. Similarly, you have got why f2 is not a function, as 1 which is in A has 2 images, 2 and 3 in B, right? Now see this question number 1. It says that if x equals to, if x and y belongs to this set 1, 2, 3, 4, which is the set of first 4 natural numbers, then which of the following are functions on the given set? So first function, let us check for this, right? First function is f1 equals to the set of all those ordered pair x comma y such that y equals to x plus 1. So since x comma y belongs to f1, we need to satisfy this condition. Which condition? This, y equals to x plus 1. We assume that this x and y which belongs to this set, we name this set as A, right? We name this set as A. Let A equals to 1, 2, 3, 4. Then x belongs to A and y belongs to A, right? Now check for this condition, y equals to x plus 1. Now put x equals to 1 in this equation, right? Then y equals to, in place of x put 1, 1 plus 1 which is 2. Then put x equals to 2. Then y equals to 2 plus 1 is 3. Then put x equals to 3. Then y equals to 3 plus 1 is 4. And see here, this x and y should belong to A, right? So here 1, 2, 3 and 4 belong to A. But as soon as you put this, you put x equal to 4 here, then y is 5, which does not belong to set A, right? So 4 has no image in its codomain, right? Here this 4 has no image in this set, therefore f1 is not a function from set A to set A, right? Clearly f1 is not a function, as 4 which belongs to this first set A, this set has no image in its codomain, which is set A itself, right? Therefore option A was this, f1 equals to this. This is not a function, right? Similarly you may check for f2. f2 must satisfy x plus y greater than 4. So take x equals to 1, then 1 plus y is greater than 4. This condition holds. Take 1 to the RHS, we get y greater than 4 minus 1 or y greater than 3, and see y belongs to this set A, right? So y greater than 3 means y is 4, right? Therefore we get the first ordered pair of f2 as this. Now similarly you may put x equals to 2, 3 and 4 and check what are the values you get for y. But notice that x and y should belong to the set A, and this condition also holds. So you will get your f2 as this, right? Now you observe that 3, 4 and 3, 2, 3, 3. This in these three ordered pairs, 3 is the first element which is common, right? And we have just learned that no two ordered pair can have the same first element. Then by that definition we can say that f2 is not a function from A to B, right? Clearly f2 is not a function from set A to A, right? As 3 belongs to A has more than one image in A. You can draw its arrow diagram as this. This is left as a homework for you, right? Similarly you may check f3. Here f3 is also not a function from A to A, as this element 3 has more than 2 images in this set B, as 1 and 2, right? Also you may say that this element 4 has no image in this codomain, therefore it is not a function from set A to set A. Next, f4. For f4 we check again this condition. Here this is our set A, right? This is a function as, check here, as f4 satisfies both the conditions, means no two ordered pair have the same first element, and every element of this set A has an image in set B, and therefore f4 is a function from set A to set A, right? Now the domain of f4 is this set A itself, and the range is the where the images of set A go, right? This is the, I hope this is clear to all of you. Next topic will be our function as a correspondence, which we will discuss in our next class. Thank you for watching.